Hello everyone, welcome to today's tutorial. Today we'll cover tutorial 8, which will be on translation task using Hugging Face. So similar to the summarization task that we did using Hugging Face, this will be similar, but it will be a translation task. It will be on machine translation. So let's say if your input is English and we want to convert it to Hindi, then what are their models, what are the techniques that we do, and how can we do that using Transformers library from Hugging Face. So let's get started. So we need to connect to the GPU runtime. As you can see, I have connected to it. Let's import packages. Let's install the packages that needed. So Transformers, so sentence piece. So sentence piece is a library that is used for tokenization of the sentences. It is similar to BPE and other tokenization algorithms that are there. And we need evaluate and another sort for the evaluate matrices, and another library that we need is the datasets package from Hugging Face, which is used to get the datasets from the Hugging Face hub. So first let's see the Transformers version that we are currently using, and we need to make sure we are at least 4.11. So it's 4.48, so we are pretty good to go. So fine tuning a model on translation tasks. So in this notebook we will see how to fine tune one of the transformer models for a translation task. We will use the WMT dataset, which is a publicly available dataset. So the dataset can be, you can get the dataset from here, or they are also uploaded onto the Hugging Face. A machine translation dataset composed of from a collection of various sources, including news commentaries and parliament proceedings. So this is a screenshot from the hosted inference API. So my name is Sarah and I live in London, and this is to some language which I can't read using the API. So we will see how to easily load the dataset using the Hugging Face Transformers datasets, and how to fine tune it using the trainer API from Hugging Face. And so model checkpoint that we are using is the Helsinki NLP Opus MTEN RO dataset. So we are converting from English to Romanian. So this is the model page for the model. You can go ahead and choose try with other translation architectures, such as there is very popular, the No Language Left Behind 200, Distill 600 million. So this is by Facebook, and it has been pre-trained with around 200 languages, and especially for low resource languages. So as you can see, especially for low resource languages, and you can go ahead and put this here, copy this and paste it here, and you can go ahead and train an NLP model to do the similar task. But for and there is another model that is also from Facebook. This is MBART Large 50, which is, I think it came around 2020. It covers around 50 languages, and these are the languages that are covered. And this is also a popular model, and so you can also fine tune MBART Large 50 and see, and have a benchmarking kind of setup where you can do a survey which model performs better on this translation task for the particular source and target sentences. So let's say for low resource to low resource, for let's say Sanskrit to Malayalam, for Sanskrit to Bengali, let's say for Sanskrit to Hebrew, let's say which model performs good. And also you need to find data sets that are big enough so that you can fine tune these large language models. Your data sets can't be around, let's say 500 or 1000 sentences. then there's no point on running these big LLMs. It will never be trained. So we have loaded the model, then we load the dataset using the load dataset from datasets, and for the metric we are using BLEU from the evaluate package, and so this we are getting the WMT16 from the model hub, and we are taking the ROEN split. So as you can see, the dataset is getting downloaded. So the dataset is getting downloaded. So train, validation, test, and the splits are also getting downloaded. So it's been done. So let's see what is in our raw datasets. So it is a dictionary. So around 6 lakhs training samples, validation around 2000, and test around 2000. So pretty good test, train, test, split. And let's say we see a random sample from the training split. So membership of the parliament, see minutes, and the corresponding Romanian sample of the English. So this is a helper function, so that you can visualize how the dataset looks like, and it is something like this. So sample 1 we have EN, RO, and similarly here we have shown only 5. So 5 samples. You can go ahead and do a 10 and see how these 10 samples looks like, the top 10 samples. As you can see, these are top 10 samples. So as you can also see, there are quite big sentences also, and so you need to take care of the max length, max source target length, and the max target length that you are giving it in the trainer API. So let's check the metric. What is the metric that we are showing? So it is BLEU metric. So computes the BLEU score of the translated segments against one of the references, and this is the signature of how the model is. So there is also an example given. So pretty well defined signature is there. Let's give a dry run of the BLEU metric. So fake predictions, fake labels. So as you can see, the BLEU is pretty 0 because so, and also this is the average BLEU of, so BLEU 1, BLEU 2, BLEU 3, BLEU 4. So this average of all the BLEU metrics is what is being reported here. Now before we feed these texts, those texts to our model, we need to pre-process them. This is also done by the transformers library known as the tokenizer, which tokenizes the input and converting them to corresponding tokens, to their corresponding IDs in the pretrained vocabulary, and put it in a format that the model expects, as well as to generate the other inputs that the model requires. So we will call the auto tokenizer from pretrained method. So this is a pretrained model. So as this model is a pretrained model, so we will call auto tokenizer from pretrained, because this has already been pretrained on this empty task from EN to RO, from English to Romanian. So we will call this from pretrained, and this vocabulary, so the vocabulary will be cached. So as you can see, config.json, so this vocab.json contains the vocabulary of the model, and it has been cached in our local system here in our Colab. So the model and so different types of tokenizers accept the source language in a different way. So if we are passing in mbert, we need to pass the source language like en.xx and tokenizer .target language as ro.ro, which you can see from here. All the languages and their codes are given here. So this is how the mbert tokenizer accepts the languages, and this is different from NLLB, from MT5, and for this model also. So this mbert accepts it like this way. So you need to check out the language codes. You can check here, and you can check out the language codes for mbert. So this is mbert large 25, and these are all the language codes. So let's tokenize and let's dry run. So hello, this is the sentence, this is the input IDs, and this is the attention mask. So depending on the model selected, you will see different keys in the vocabulary returned by SL. So this will be different depending upon the different language, depending on the different model, and also let's run. So as you can see, these are two sentences. So we have a list of lists and the attention masks. Now to prepare the target of our model, we also need to tokenize the target, and that is done by a target tokenizer context manager. Okay, so the model will give output in terms of these IDs. So we also need to make the model understand what are these IDs in terms of targets. So we convert these convert the targets to the IDs also, to corresponding IDs, and that is done by tokenizer as target tokenizer method context manager. And so if we are using any T5 checkpoints, T5 checkpoints have a prefix added to the before the task, as we saw previously in terms of summarization. We have used a MT5 model. So if the model checkpoint is it's a T5 model, we need to add the prefix translate English to Romanian, and if it's not a T5 model, we can just skip it. So we can write the function that will preprocess our samples. We just feed them to the tokenizer argument with truncation equal to true, and this will ensure that the input longer than the model selected can handle will be truncated to maximum length accepted by the model. So if we are setting the maximum input length to 128, if a sample comes which after tokenization becomes 160, it will be truncated to 128. Similarly for the target length. So while you are visualizing or getting some statistics from your data set, you should always see what is the minimum, what is the average maximum, what is the average length, the maximum length, the mean length of the data set that you are going to fine tune on. So this is a preprocess function which inputs and targets takes inputs and targets from the data set and tokenizes them. So these are the inputs to the model, these are the labels to the model, and so model inputs dot labels equals to labels dot input IDs, and we are returning the input IDs. So everything is that the model requires is in input IDs. So let's say we provide the first two samples to the preprocess function. As you can see, we have input IDs, we have labels, we have attention masks, and so on and so forth for the first two samples. Now what we do, we need to tokenize the whole data set. So we would run this preprocess function on the raw data sets, and we can do this using a map function, and we should always do bashed equal to true, so that it's a bit faster. So if you run this will take around 5 minutes. We can just move ahead. So even better, the results that are automatically cached by the datasets library. So these are automatically cached by the tokenizers, by the datasets library from Hugging Face. So I mean, for instance, it will be properly detect if you change the task from the first cell and return the notebook. Datasets wants you when it uses cached files, so you can pass load cache from file equal to false in the call to map to not use the cache files and force the preprocessing to be applied again. So let's say you change the preprocess function, and then you do the tokenized datasets, but what this .map will do, it will take the old preprocessed dataset from the cache and not run it again. So you should change this, you should change the load from cache file to false, so that the preprocess function can be run again on the whole dataset. Now fine tuning the model. So from transformers we import, so we would so since this is a sec to sec, sequence to sequence task, we use auto model for sec to sec LM class. So auto model for sec to sec LM. So if you go ahead and look at it, so these are the auto classes, all the auto classes. So Hugging Face is smart enough, so depending upon the model it passes to the auto class, it will take so if you pass a BERT based model to the auto model, the model will create an instance of BERT model, right. So similarly for other cases, so it is a sec to sec task, so auto model for sec to sec LM. So these are the parameters that the model takes. This is the configs, pretrained from pretrained config. So this is from pretrained. This is the function that we are using. So this is what the model parameters that the model can take, that the function can take, and it accepts configurations from these different kind of models. This is for TensorFlow if anyone is using it. So we need auto model for sec to sec LM, data collator for sec to sec training arguments, and sec to sec trainer. So sec to sec training arguments and sec to sec trainer are basically taken from the trainer and the training arguments APIs, and they are particularly done for a sequence to sequence task like translation, summarization, question generation, and so on and so forth. So we are taking the model. So from pretrained we are putting it here, model checkpoint. So this is it will take another 1.25 minutes. So to instantiate a sec to sec trainer, we need to define three things. So the three more things. So the most important thing of the sec to sec training arguments is the class. So this is the class, which is a class that contains all the attributes that are required for training, to customize the training. So let's go ahead and look at the doc. So when you are not sure of what this function does, you should always go ahead and look at the docs. As you can see, sec to sec training arguments can take 121 parameters, and you should probably look at it in first time, so that you can easily go ahead and look it up where this thing is. So do train, do eval, do predict, prediction loss, you can change the eval accumulation steps, you can change the gradient accumulation steps. So this is the number of update steps to accumulate gradients for before performing a backward or an update pass, right. So you can cache the gradients. So if gradient accumulation is 2, the updates will happen after 2 steps, after 2 steps for the forward pass of the model. So 2 steps forward, one backward. So and the gradients will be cached for the second time when the backward pass is happening. So this is used when you have a smaller GPU and the backward gradient storage is not there. So but it is a little bit slower since the gradients are cached and it is happening after 2 steps. Similarly for eval also you can do. Then we have learning, you can change the learning rate, you can weight decay, ADAM parameters, then we have max steps, we have number of training epochs that we want to do. We have the learning rate scheduler, that how do you want to schedule the learning rate. You can also schedule the learning rate of the model. It does not have to be normal like 2 into e to the power minus 5 or something like that. You can also schedule like it is linear. So by default it is linear. It can be cosine, so it can be cosine, which restarts, it can be polynomial, constant, and so on and so forth. Then we have safe strategies. How do you want to log up strategies, many warm up steps that you want to do before. So this warm up steps is the number of steps used for a linear warm up from 0 to learning rate, right. Then we have safe strategies, safe steps. Then we have whole lot of mixed precision parameters, like we want to use bfloat 16 or fp16 or full eval, half eval, tf32. So by default we use fp32, not tf32. And we want to use FSDP. So this is PyTorch distributed parallel training in a distributed training only, we need to handle this FSDP config, and we need to pass this FSDP config according to our GPU's multi-GPU things and do sharding and so on and so forth. Then we have deep speed. So, deep speed is a utility to train large language models for distributed training only, and it has a lot of things that you can tweak to run models and so on and so forth. So, DeepSeek 03 is very popular. DeepSeek, it came 01, 02, 03. It can also offload your parameters that you are not using, that will not be used currently, to the CPU, so that you can use a big chunk that will be taken up by those parameters that will not be used right now for for training your model. Then we have accelerator config, that is via Hugging Face. Also, then we have optim parameters, hub strategy, how will you upload the models to the hub, and what will be the torch compile backend. So, now PyTorch 2.0 is very powerful in the compile torch.compile backend. How will you use those? And please go ahead and so this is one important thing, just generation max length and generation config. So, how do you want to generate the tokens that are coming out of the model? So, do you want greedy decoding or beam search or sampling? How do you want to sample the tokens that are coming out? You can go ahead and look at these. So, this is the greedy. So, this is the generation config that you can send to the sec-to-sec training arguments. So, as you can see, you can do greedy decoding, contrastive search, multinomial sampling, beam search decoding, beam search multinomial sampling, diverse beam search decoding, and please go ahead and look at the docs for more details. So, I think our model has been mapped. Yeah, our model has been cached. So, this is the model is currently being downloaded from the hub. Oh, so it has been downloaded. So, here in the sec-to-sec training arguments, we put the evaluation strategy, the learning rate, the per device trained batch size is the batch size that we want to use during training. So, it is 16 in our case, and this is the evaluation batch size. Evaluation batch size can be higher than the training batch size because it is doing only inference. So, this is the weight decay, the save total limits, how many times we want to save our model checkpoints, number of epochs. Since this is a dry run, we can do only one, and predict with generate is for generating the summaries, generating the translations for our case, and then FP16 for mixed precision training, so that our training will be a little bit faster. And this is the push to hub, like you want to push your model to the model hub of Hugging Face. For now, we are doing it false. So, training arguments has been set. Yeah. So, and now then we want to do data collator for sec-to-sec, which not only pads the inputs to maximum length, but also pads the labels. The last thing that we want our sec-to-sec trainer is how to compute, sec-to-sec trainer is how to compute metrics for the predictions, right. So, we need to have a metric as to how our model is performing. So, for our case, since the translation task, we are using BLEU. This is a simple compute metrics function that does that. Now, we are passing everything to our sec-to-sec trainer. We are passing the models, the args. Args are basically the sec-to-sec training arguments that we have passed. Then we are passing the training data set, the evaluation data set, the data collator function, the tokenizer that is being used by the model, and the compute metrics function. So, the trainer API has been instantiated according to our use case, and we can just run the model using the trainer.train function. So, if I click on this, the training will be started. So, yeah, so I think so here by default there is something known as weights and biases. So here this is a logging platform where you can check out the the loss graphs, the predictions, and so on and so forth. So by default, here we have something known as report to. So if I report to, so here, so as you can see, report to, so this is the list of integrations to report the result and logs to. So several platforms are there like Azure ML, Clear ML, Code Carbon, Comet LM, DAGS Hub, DCV Live Flight, and so on and so forth. So via default, it uses all, so it will report to all the integrations if you have given the access to the API. If you don't want to use it, we can just report none. So here we will say report to none, so that it doesn't report anywhere. So currently it is asking for the weights and biases API, so that it can start logging the runs of our model into weights and biases. Currently we don't want to do that, so we just put report to none. And now if we start training, it will, as you can see, so it will start training. So as you can see, it will take around 1.5 hours, 1 hour to start the training. So you can go ahead and start training in your Colab. I am pausing it for now, and you can upload the result to the Hugging Face by just executing this. So trainer push to hub, it will ask you for the Hugging Face profile profile token, and then you can just and then you can also use that that model using the model that you are trying to save. So I think the name, yeah, so this is the model name, and this is the same model name that will be uploaded on the hub. So you can also use that model that you just trained for further usage. That's all for today. Please go ahead and try other models like NLB, MBART, Large 50, MT5 for translation tasks, and yeah, we will update this in the course website. Thank you.